Welcome back. In this problem, we will be demonstrating how to create a payroll register, which is something that all companies use in one form or another. Either they do the payroll in-house and have something similar to this payroll register that you're about to see, or they subcontract their payroll out and have ADP or Paychex or a similar service compute the payroll for them. But in any case, be assured that some type of a payroll register is being used. I believe that this problem will show you one of the most powerful features in Excel called the equals if statement. And it's very powerful. It is one of the decision-making statements that we will be covering this semester. So please pay attention to this problem and give it the attention it deserves. The equals if function has many places in your everyday lives. So as always, you should have retrieved both the directions and the Excel file from the Canvas platform. In addition, for the payroll register problem, there's also a supplementary handout that will go through each formula step by step. So make sure that you've downloaded that extra supplemental file. It will make your life much easier. The goals in this problem are to be able to prepare and use a payroll register, to learn how to use an equals if statement and the equals round function, to be able to record journal entries for payroll related transactions, to be able to identify and interpret payroll taxes, to be able to alter the payroll register to accept new employees, and be able to interpret data on charts as well as prepare one. One of the most important parts of this problem is your ability to understand and use an equals if statement. So let's take a moment to look up how the statement is created. It is a very powerful decision-making statement. It allows the user to define criteria so that the computer can make a decision based on whether the criteria tested is true or false. It looks like this: equals if with three things inside the parentheses with the variables separated by commas. So first we'll put in the criteria to be tested, and then we'll put in a comma, followed by what we want the computer to do if the result is true, followed by what we want the computer to do if the result is false. And if you have more than two decisions within one equals if statement, you can nest them. I'll be demonstrating this shortly. You might want to take a moment to pause the video right now and take another look at how an equals if statement is set up. We'll start off by demonstrating a simple equals if statement as it relates to union dues. Specifically, we'll be dealing with Formula 4. And I've put the formula in here. It's also on your supplementary handout, and I'll be demonstrating it to you momentarily. But this is the way it's set up. Equals if the contents of B13 equals yes, that's the criteria to be tested. If that's true, the computer's going to put $50 as a result. That's the amount of the union dues charge. If it's not true, or if it's false, then the computer will put a 0 in the cell, meaning that 0 union dues will be charged if the employee is not a union member. So again, this means that the computer will go test cell B13, that was the first part of the formula. If it contains that yes, that was the condition to be tested, then the computer will go to the true part of the formula and insert the $50. Here's the true result. If it's not true, then the computer will jump to the false result and enter the false result of 0. Here's the false result. Again, you can nest equals if statements if there are more than two results. Let's start off the Excel demonstration by demonstrating a simple equals if statement. So here's our Excel spreadsheet that you should have downloaded from Canvas, and right now we're going to be looking at a simple equals if statement, specifically Formula 4. So once again, the equals if statement starts out with equals if and a parentheses, and here the computer will tell you the format. We need to put in the test, the logical test. We'll follow it with a true value and a false value. So our test is if this cell, B13, is equal to, I'm going to put yes in quotes because that's a label, then we want to charge $50 for the union dues, and if it's not true, we want to jump to the false result, which is 0. And after I enter that in, you'll see that in this case, since Amber is a union member, the computer correctly charged her $50. Now let's go take a look at a more sophisticated equals if statement, one that will deal with Social Security tax. So Social Security becomes a bit more involved because unlike the union dues example, this one has more than 2 possible results. Let me explain. Since Social Security has a maximum or a cap associated with it, we need to use nested equals if statements. This is because the equals if statement is used to handle only 2 scenarios. For example, a true result and a false result. But because of the maximum cap, there are actually 3 scenarios that may happen. I've recapped them for you in this slide, and they're also explained in more detail in the supplementary handout. So here's the 3 scenarios. The Social Security maximum changes each year. For this example, the Social Security is assumed to be $118,500 for the year. This was the rate in 2017. So here's the 3 things that can happen. If the worker is above that max or cap, in other words, if he's already made $118,500, then no tax would be due. However, if the worker is close to the maximum, then some of his next paycheck will have taxes calculated. The third scenario and last one is if the worker is below the maximum, all the wages are taxed. And once again, please refer to the supplementary handout for a summary of all the formulas. So we're going to go take a look at the Excel spreadsheet and get ready to compute Social Security using a more sophisticated nested if statement. So here we go with Formula 1. Again, follow along with the supplementary handout. This formula is written in there for you. We want to start out by saying if this employee has already earned more than the max, then we want his Social Security tax to be 0. So before I get going with that scenario, let's go put the first amount inside cell I13, which is the cumulative gross pay. In case 1 on your handout, we're assuming that Amber's taxable wages through the last payroll period were $90,000. Having said that, let's go try our formula. So our first condition to be tested is going to see whether Amber's payroll located in cell I13, if that's greater than the payroll maximum, which is down here in cell G25. If that's true, then we want the payroll to be 0. Now comes the nested part of the equals if statement. We can't just put in a false result because of those 3 possible scenarios that we just discussed. So the second part of the formula is going to be to test whether Amber went over or is close to going over the maximum. We just tested to see if she was over it. Now we're going to test to see whether this payroll puts her over it. So now let's test to see whether this payroll for October pushes her over. So now we want to introduce our second or nested equals if statement to see if the payroll that she's made year to date plus the payroll that she's earned in October, we want to check if this pushes her over that maximum down here in G25. Then we only want to calculate the tax on how far away she is from going over. In other words, we would want to tax the difference between this maximum less what she's made to date multiplied by the tax rate. The tax rate for Social Security is located here in this cell. Otherwise, if none of these conditions are true, there's only one false result left. So let's back up. The first thing we did is test to see whether her pay so far to date pushed her over the limit. If it did, the true result said put 0 tax in there. If that wasn't the case, then we further went on to test to see if this paycheck pushed her over the limit. In other words, we tested to see whether the cumulative gross pay plus this period put her over the max. If that was the case, then we wanted to tax the difference between the maximum and the year-to-date amount. The only other possible result that could happen is that she's below the max, in which case we would tax the whole thing. So here comes my false result. I'm going to take her gross pay for this period multiplied by the current tax rate. And that's our equals if statement. We have one more thing to worry about. It's called Excel syntax, and we want to check to make sure the open parentheses match the closed parentheses. And if they don't, we need to fix it. So here's 1 open, 2 open, 3 open. And so I need to have at least 3, well, I need to have exactly 3 closed. Right now I have 1, 2, here's my third one. And it's telling me that I have to check a little bit farther. So let me take a look one more time at the formula and see what I need to fix. And here's what I forgot. Right here, I needed an open parentheses because I needed one for the equals if statement and another one so that these two items would be compared to G25. So now that I've added that, let me put another closed and let's see what happens. I pressed enter and here's the result that I got. You should be comparing this to the manual calculations that you did in the instructions in requirement 1. There were 3 cases for Amber. You want to check and make sure that the manual amount you wrote down is correct. Okay, now I want to take another look at that formula. Later on, you're going to be adding another new employee. And it would be a shame to have to re-enter this formula. So in the lessons in your step-by-step book, one of the things you read about was the difference between a relative cell address and an absolute cell address. When we copy these down, we want some of these cell references to change, but others we want to keep the same. In other words, when I copy this formula down to Bobby, the second employee, I want line I-13 to change to I-14. In fact, I want everything related to the 13th line to change. However, I want anything related to these tax rates to be static. I don't want them to change as I copy the formula. So anything that shows up in this gray box needs to be absolute referenced. You can do an absolute reference one of 2 ways. You can hard enter a $sign in front of the cell, or what I like is if you highlight the item, you can press the F4 key and automatically have the F4 key put the cell reference in there. So again, by hitting the F4 key, you can put an absolute reference, which means those items won't change as you copy them down. So anything that falls within the G area down here, you want to put within the absolute reference. So that means I want to put an absolute reference here, an absolute reference here, because that falls in that gray box below, an absolute reference here, and an absolute reference here. I did not want an absolute reference on that line item, so I accidentally hit it, so I'll toggle between the F4 buttons until I get that back to be a regular cell address. It toggles between the various absolute choices. So again, let's take another look. That's a long formula, and to some people it's confusing, but it's very powerful. So once again, I'm testing to see whether her cumulative gross pay is greater than the maximum. If it is, my true result is to enter 0 in the Social Security tax deduction column. The second condition is if this payroll plus her cumulative cumulative gross pay pushed her over the max, then you want to just calculate the difference. The false result, if none of those two are true, then tax the whole thing. Then we went through and put absolute references using the F4 key on anything that was in this gray box that we didn't want to change. The other option is as you're typing in the formula, if you hit the F4 key as soon as you've typed in the cell, it will change it for you that way as well. If that wasn't enough to learn, this lesson also introduces you to a round function. We'll take a look at that on the slide presentation before I introduce it to you on the Excel spreadsheet. The round statement was developed to prevent errors from rounding to accumulate in totals and having totals be off by a few dollars. It's useful when you're multiplying by decimals. Some numbers can be very long. What happens is the computer stores many decimal places inside its memory in the Excel program. So we use this function to prevent rounding errors when multiplying by a decimal. So if you think about the payroll problem that we're working on right now, both Social Security and Medicare have some decimal places in it, so we'll use the round statement to prevent the rounding errors from happening. And here is how it's set up. You put equals round at the front end, and at the back end you put the number of decimal places that you would like to round to. So since payroll deals with dollars and cents, we'll be putting 2 decimal places in our formula. So let's go adjust the formula that we just did in Excel to round to 2 decimal places. So here we go. In the formula bar here, we're still looking at the first formula for Social Security taxes. I'm going to add the round function to this by going to the front of the formula and typing equals round, and then going to the back of the formula and putting a comma with 2, meaning round to 2 decimal places. That will keep our totals on line 18 from being off due to rounding errors. I'm going to press enter, and here's my result. So let's take a look at a couple of other formulas. Let me put the federal income tax in from your handout from Amber Adia. This would normally be taken from a circular E, but we're going to be giving it to you in the interest of making the problem a little bit easier. So Amber's federal tax is $785. Medicare tax is just a straight formula. There are no caps. In fact, there's a surcharge that we're not going to worry about. But for the rate in 2017 is 1.45%. Since that has a couple of decimals, it would be wise to use an equals round formula. So here we go, equals round. And then we want to take her gross pay times the Medicare rate. And since I don't want that to change as I copy it, I'm going to use the F4 key to make sure that that's an absolute reference. And then I'm going to end that formula, and I'm going to put comma 2. And again, the open parentheses need to match the closed parentheses, so I need one more open to get that formula to work. And I'm ready to press enter. The union dues were already calculated, so the net pay is what I have left for Amber. And the net pay is going to be the gross less the sum of her deductions, which range from D13 to G13. Let me try that one more time. They range from D13 to G13, and when I pop that in there, $3,967.20 is her net pay. So if you've done these formulas properly, which means you have entered the absolute references on anything in the gray box, you should be able to copy that formula down to formula 2. In other words, grab the fill handle and drag it down. Now the reason that she has 0 Social Security tax is because I haven't put in Bobby's gross pay. From your handout, that would be $4,300. Okay, so you'll notice that the rest of the formulas pop in as soon as you finish the given formulas. Here, since it's a relative cell address, when I copy this down, that B13 will change to B14. And after I have all my formulas in, and as soon as I enter these items from the handout, the rest of the template should compute automatically. So let me go ahead and do that. I'm going to pause this while I enter the rest of the information. So now that I've entered all the information here in blue, everything else has recomputed, and you can test to see whether your net pay, I'll put it in red, matches mine. Okay, so once again, much of the instruction is in the supplementary handout. It summarizes all the formulas for this problem. Make sure you take a moment to read through it. With all problems, you will also be creating a chart. As always, make sure you have a 3-part title, who, what, when. Make your chart the best it can be. Consider using data labels. In this case, you'll definitely want to show the percentage of each of the taxes and the resulting net pay for the given employee. If you still aren't comfortable preparing charts, please go back and review the lesson on charts in your step-by-step book, since that's an integral part of this class. So what's next? As always, complete the problem according to the directions, double check the requirements, make sure your work prints out properly. Each page should be able to print out on one given page. After double checking that you've completed all parts of the problem, upload the one final Excel file to me through Canvas. Make sure that you check the discussion post to see if anything applies to this problem. And as always, if you need help, you know how to reach me. Until next time, see you later.